Page 30, question number 12, just to kind of recap um, what we've already know about the elimination method, and then we're going to be adding to the elimination method today by doing multiplication along with it, okay? So in this particular problem, we can tell that the y terms are opposite of each other, so that's why we want them to be eliminated. So that's why it's called elimination. So when we combine these together by adding, okay, the y terms cancel out, and we're going to end up with negative 4x equals to positive 8. And then, of course, when you divide, you get x equals to negative 2. So we already know how to do that. Okay, it was already set up where we could either add them together or subtract them, so one of the variables would be eliminated. So after you get one of them eliminated, you solve for the one that's left, which was what we just did. Then you can substitute this answer into either one of these x's here at the top, the first equation or the second, to solve for y. So I'm just going to go back to the first. Okay. So I'm going to have 5 times negative 2 plus the 3y equals to negative 1. So this will give me negative 10 plus 3y equals negative 1. And then I'm going to add the 10 to the other side. So I have 3y equals 9, so y equals to 3. So when you put your coordinates together, your y coordinate, your x coordinate first, and then your y coordinate. Okay, so that is what we already know how to do with using the elimination. Now what we're going to do is go to page 11 and 12 in your packets. So have out your study guide packets and our notes for today. And this says elimination with multiplication. So yes, it's going to still involve the elimination method, but before we can eliminate, we'll have to multiply either one equation or both equations by some number in order for the variables to cancel each other out. Okay, so some of this you'll have a choice. So let's look at the first one. So notice that in this problem, you don't have any coefficients that are either the opposites of each other or the same. Like I don't have a 1 here and a 1 here, or a negative 4 and a positive 4 here. So that means I have to decide how am I going to eliminate one of these variables. Okay, so this is where you get to choose. So let's just say, for instance, let's just say I wanted to eliminate the x's. All right, because you got to choose here. If I wanted to eliminate the x's, then I would need to make the top one a negative 5, because then a negative 5 and a positive 5 would cancel out. If I wanted to eliminate the y's, well, what would I multiply this one by? A positive what? 4, because then I would have a positive 4 and a negative 4, and they would be eliminated. So that's why it's called elimination with multiplication, because now you need to decide which variable you would like to eliminate and then multiply in order for that to happen. Okay, that's really the basis here. So if I would actually rather do the 4s because they already have the opposite signs. So one is already negative and this one is already positive. So I'm going to multiply this entire row here by 4. And keep in mind, you cannot just multiply the y by 4. Okay, it has to be the entire equation, because then you're not changing the equation when you do the same thing to each term. All right, so let's do that. So we're going to multiply this entire equation at the bottom by 4, because we're going to eliminate the y values. So I'm just going to rewrite the first one exactly like it is, because I'm not changing that. And then the second one will be 20x plus 4y. And what is 18 times 4? Okay. So right away, these cancel out. And that is exactly what I wanted to happen. Okay, so I multiplied. Now, could you have eliminated the x's? Absolutely. You would have multiplied, the top row by -5. Okay, so let's go ahead and finish this. So now we have our elimination process. So we'll just combine these by adding. So this will give me 21x equals, what will this give me over here? 63. Divide by 21. So what is the value of x? 3. So how do I get my y value? Just like I got it earlier, I just plug the x back into the top or the bottom. And you can either go back to the original. I always like to go back to the original ones, not where I've actually made the numbers bigger. But I'm just going to use the top one. So I'm going back to this one here. And I'm going to say x is 3 minus 4y equals -9. Okay, subtract 3. So y equals a +3. So my answer is 3, 3. Okay. So again, this is elimination with multiplication. All right, let's take a look at question number 2. All right, so in question number 2, I don't have any coefficients that are at least opposite sides. Everything's positive. So I just need to choose again. Do I want to eliminate the x's? Do I want to eliminate the y's? I'm just going to do the y's just because the y's are smaller numbers. Okay, that's what I like to work with, smaller numbers. So I'm going to do the y's. So if this is a +2y at the bottom, what do I want the one at the top to be? A -2, right? So that means I'm going to multiply this entire equation by -2. All right, so that's going to change that to -12x minus 2y equals -24. And then I just rewrite the other one exactly like it is. Okay, so really the only new part of this lesson is to do that multiplication. So one of your variables can be eliminated. So that eliminates that. And then I'll have -11x equals what will this give me? -11. And then when I divide, I get a +1. Okay. So now I'll just put it back into one of the other equations. I'll probably just use this one here because I like smaller numbers. So x is 1. So I'm going to say 1 plus 2y equals 13. Subtract 1, 2y equals 12. So y equals 6. Okay, and then you write your final answer as a coordinate. Okay, everything's just the same. All right. So we're going to do one more of these, and then I'm going to talk about the word problems, because remember in the other methods, we've only been setting the word problems up. So today we're not only going to set them up, but we're going to also go back and solve them. Okay, because now we have this method that we can use to solve them. All right, so let's take a look at, let's do number 4, okay? So in number 4, again, you decide if you want to eliminate x's or you want to eliminate y's, okay? Here, I'm just going to do the x's. So if I do the x's, I would have to multiply the top one by what? 5, very good. So this will give me -5x plus 5y equals 0. And then I'm just going to rewrite the other one right underneath. Okay, the x's cancel out right away. And then I end up with -y equals to -1. Divide by the negative, that equals to +1. Okay, then I'm going to put this back into the Doesn't matter. I'll choose the first one. So I'm going to replace y with 1. And solve that. So my answer is 1, 1. Okay. All right. So now let's move on to the word problem. Now, notice in this one, actually, before I move on to the word problem, let me just help you rearrange this first, because it even says solve each system by elimination, but rearrange it first. Rearrange it just simply means, this x has to be over here and the constant has to be over here. So let's go ahead and rearrange these two, so when you have to finish this, they'll already be in the correct order, okay? All right, so how do I get this 3x to the other side? Since it's positive, how do I get it to the other side? Subtract, use the opposite side. Okay, so that's going to make that a negative 3x plus 3y. And then to move this over, again, use the opposite side. So again, move this over, so that's a negative 12x plus y equals negative 5. So you just use the opposite sign to get it to the other side. So here, move that over, that'll be 16x minus 5y, and negative 24x plus 3y. Okay, so at least now it'll be in the right order. Now, let me just point something out here. These problems, these type of problems, you cannot just multiply like the first one by something and then something's going to be eliminated. So let's take a look at number 10, for instance. Sometimes you have to change both equations. It may not work like here. I can't make this a positive 5. Okay, I can't make this a positive 24, so these will cancel out. So sometimes you'll have to change both equations, multiply both equations in order for your variable to be eliminated. So what do I mean by that? So if this is 16 and negative 24, I can't change either one of those to be eliminated. However, I can take these y's and make both of them 15. Okay, so it's almost like getting the least common denominator of 5 and 3 is 15. So you can change them so both of them would be 15. One will be a negative 15. So if I want the top one to be a negative 15, I would have to multiply this one by what number? 3. If I want the bottom one to be a positive 15, I would have to multiply this by what? 5. So it's not going to be a situation where, like we just did those first few examples, where we only had to change one equation. Sometimes you might have to change both. So I want you to see that and not think that, oh, what happened? Because I can't only change one. You're right. Sometimes you might have to change both. Okay? So I'm going to leave that there. Let's look at the word problems. This is what I really want to take a look at with you, because now we're going to actually solve these word problems. We've only been setting them up, but now we're going to write the two equations and we're going to solve them. And then after we do these two, we're going to go back to pages, what did I have on the agenda today? We're going to go back to pages 3 and 5, and they're already set up, but now we're going to actually go back and solve those word problems on pages 3 and 5. Okay? All right. Sorry, I got the wrong one. Okay. So here we go. Remember how we had to define our variable? It says the school that Mary goes to is selling tickets to the annual talent show. On the first day of the ticket sales, the school sold 2 senior citizens tickets and 6 students tickets. So I'm going to just say let X equal senior citizen. So we're going to define our variables, and let's say Y equals the student tickets. Okay. So those are our two variables. Now you could definitely use C for senior, or S for student, whatever you want to, but as long as you define what your variables will represent. So the first day of the ticket sale, the school sold 2 senior citizens, so that's 2X, plus 6 students, so that's 6Y, for a total of $90. And then the school took in $204 on the second day by selling 4 senior citizens and 14 students. Okay, so now we have our 2 equations set up. We define our variables, and now we need to solve this. So we're going to be solving using the method that we learned today. So let me ask you, which variable do you think I should eliminate? The X's or the Y's? X's, okay. So this is a 2 and this is a 4. So I would probably want the bottom one, the top one that is, to be a -4. So I need to multiply everything by what? -2. Okay. So when I do that, that's going to make this be a -4x minus 6y equals a -180. And then the bottom, I'll have 4x plus 14y equals 204. Okay. Cancel out our x's. Let me make sure. Did I multiply that y term by -2? Right here, yes. Okay, so let me change this right here. This should actually be -12. Is that right? Okay. So that should be a -12. So for my y's, I'm going to end up with what? A positive 2y. And what is 204 minus 180? Who can tell me? All right, 24. So when I divide by 2, y equals to what? 12? All right. So I already know y was student tickets. I already know I got 12 student tickets. And now how do I get the senior citizens? So I can plug it back into either one. It doesn't matter. So let's just do the top one here. I'm going to go back to the original. I'm going to say 2x plus 6 times 12 equals to 90. 2x plus 72. Okay. And then 2x equals, what's 90 minus 72? 18. And divide by 2, so x equals to 9. Is that correct? So now I have, for my senior citizens, so you would actually say 9 senior citizens tickets and 12 student tickets. Okay, so now we could actually, yes, find the price of the senior citizen ticket and the price of each student ticket. Oh, so this is actually the money. I'm sorry. So these are actually in dollars. Okay, you're absolutely correct. So this would be $9 for the senior citizens and $12 for the student tickets. That's correct. All right. So I'm going to have you guys look at question number 12 on your own or with people at your table. And then I will come back and make sure everybody has the right solution. Okay, so go ahead and work on that. All right. So the final answer for this would be, again, 9 vans and 56 buses. Was that it? That's a big number. What was the question? How many students can a bus carry? All right, I was going to say, because I know that can't be 56 buses. All right, so they can carry 56 and 9. Okay, let's go back to page 3. Now, on page 3, remember, again, when we started this unit, we only set up the word problems, but we did not solve them, okay? So you should already have these already set up. Is that correct? You should already have them set up. So now what you're going to do for part of your classwork today is to finish up solving these word problems. Okay, so now you know the method to use, multiplication with elimination. All right, so you're going to go ahead now and solve questions 7 and 8, and then you're going to go to page 5. I believe it's page 5, and do the same thing. Okay, you're going to solve now 9 and 10. So that's going to be part of your task that you need to finish up. So I would probably go ahead, since we haven't we just did this, so go ahead and do task 2 now. Go ahead and finish up those word problems on pages 3 and 5, and then you could go back and finish the notes on pages 11 and 12, the ones I did not do. Okay, but go ahead and at this point and finish up the word problems. There are only 2 on each page. Okay, so it shouldn't take very long.